Non sono cortini, Non era
Ok. Cominciamo. Okay, so let's continue with now. Let's learn how to operate with matrix instead of arrays. So to create matrix, we will use mat from Numpy. Okay. If you import Numpy with np, you will use np.numpy. If you import everything, mat. So let's create a 3x3 matrix A, like this, and convert to matrix with mat command. Just stop. Acabamos comenzando.
Perfetto.
Matrix. So, with mat, we convert any array to matrix. And we can operate in the same way as matrix. Okay? So let's create this one. Remember, you can type in three times a list of 3 elements, or remember, you can use also reshape and create an array of 9 elements, and with reshape say that change to 3x3. To access to the matrix is in the same way to the arrays with rows and columns. And now you can multiply A by itself to see that the multiplication is not element by element, but row by column and so on. We can calculate the transpose matrix with T, capital letters, the diagonal of the matrix with diagonal, the determinant of the matrix with that, and the eigenvalues with eigenvalues. So let's try. Come?
E poi
No, sto diventando
che non è definita la matrice, con il comando mat di A.
c'è Matt definisce.
Sì, con mat define transform an array A to a matrix. So we can operate in a metric way with it. Okay, is it working? This determinant and eigenvalues, we are using the package linear algebra, okay, which is in Numpy. So you can see how many functions you can work with linear question mark. See what can you do with this package of linear algebra. Can also find the inverse matrix and so on with the package. But the more important things here is, for example, the determinant of the matrix and the diagonal, that we will use this one, for example, to extract in the following chapter, extract the errors for the fitting, linear fitting. Any question about this? Is it clear? Okay. Can we go to the fun part, which is the linear fitting? Okay. So Numpy came with a very powerful, very useful package for linear fitting to fit any function linear way. That means also polynomial in any degree. But before that, let's see how to read complicated files. For example, we have some numbers in a file that we want to fit. For those, we are going some file that I have created, so you can download from the classroom. One is data sample, which is, you can see that is a little bit more complicated than usual. So is combined by, is a combination of numbers and letters. We have seen before how to use D-types, right? So we are now to apply this to read the matrix, the file, because we know what columns are. We know that we have 3 columns in that file in data sample.dat, the file that we have to download from our page. We have the first column is a float, the second is a float, and the third one is a string. So if we define our types, like this is a list of tuples. The first one is the name that we want to give to the keyword. So let's say that our first column is time, the second column is mass, and the third column is date. So we say, okay, call the first column time, and you expect a float number. The second column we can call mass, is a float, and the third column is we will call date, and it's a string of 25 length. Okay, so we create D types. This can be called anything because it's a variable. Okay, but will be used here to say how to read this file. So we create D types, and now we are going to use a function from Numpy, which is called gen from txt. That means generate from a txt file. Syntax is very simple. It's and everything is going to be kept here. Okay, in this new variable, which is called data. So first is the name of the file that we want to read. If we want to skip any rows, we say skip header equal 1, 2, 3. By default is 0. Then we can say delimiter, because we have separated the column by virgola così. We say what is the delimiter, it's between virgolette, and what is the D type of each column. With this keyword, D type equal what we have defined here. This could be named whatever. Okay? Unpack true means separate by rows. Remember that Numpy reads in a different way. It says all the, instead of by column, it says by row. But now with unpack true, we are telling separate by row. Each row is column, column in each row is a different data. Okay? With unpack true. Let's read this file. Download first and read it. Okay, that's the file. First, let's define the data types.
Cioè data type is, can be any name.
Any name, because everything on the left of an equal should be any, could be any name. So we call that types just to have a good coding style, so we can remember what is this for. We are creating this for using as data type. I think you will take less typing by yourself instead of copying directly from the PDF. It's very short. Okay. I recommend you just type.
U is
So
the equivalent in Fortran of A. Cioè for
U, yes, it's a string. When you use float, you don't have to give the length of the format, but for string you should, okay? Because you know it's going to read just one character or two. So we have to say how long is the character you expect. So put a long one.
And this command gen from txt is
If from Numpy.
okay, but it's the unique command that can be used to read the column of number.
No, you can use also log
The one that you have shown.
Yeah, but the powerful of this is that everything is going to be first. Now to access the data is very simple now, because we have defined time, mass, and day. Data time will be shown the first column, data mass the second, and data date the third.
Another question. Delimiter can be, cioè I can specify
Any.
any type of delimiter. Questo
Any.
is a letter.
Any.
Is the character that is used as delimiter.
Yes, if it's empty, you don't need it.
Okay.
This is if the delimiter character between columns to say this is a different element value, you don't need it if it's empty. But it could be any string. Okay. So important to
You
read.
say that I have an error.
Or in the syntax. Delimiter. Okay. Delimiter. Okay. No. ER. Delimiter. There. Okay. Data sample is not found. Where is this? It's not ls data sample, because you have to give the full length.
Okay.
Or you move to where it is, or you just give the full length in the name. Okay? So now data, parenthesis, time, for example, to show the time. No, the square. Data square parenthesis, square parenthesis. Is keyword is a string, time is a string. No. Time is what you have called to the header. One of the headers you call time, right?
Oh.
So time, that's right. String, virgola, virgoletta, virgola.
Okay.
Okay?
Read.
Okay. Read? Have you read? Perfect. All have the file read in the memory in Python?
Yeah.
All? Okay, now how can we access to the data? It's very simple. Just using the keyword of the header that we have defined here. Using time, mass, and date. Remember, those can be any that you decide, the name. So data time, data mass, access to that. Okay?
Cioè, what is the meaning of this data?
Data is this variable,
Okay.
and those are the column name that you have.
Okay. So I can print if I want to see the number. If I see
Data time, yeah, and show the values of the column called time that you have called time. So print time, mass, and day, and you will see that now time is are floats, mass are floats, and date are strings. So we have separated the different values because we have the different data value, the data type, because we have used D types there. So we have said, okay, read with this type of data, okay? So now we can plot. Let's say this is very quick. The next day, miércoles will be full lesson on how to make very fancy, beautiful plots. But now, just to see how it works, let's plot this data. So, to plot, we are using a library from Matplotlib that is called pyplot. So we import pyplot like this. Import matplotlib.pyplots as PL. It's better to use an alias for that. So there are some function that has the same name in the same than in Numpy. So we will use an alias. So with this, import the graphic library of Python. And we need two very important commands at the beginning. Which one is to make the figure interactive.
Interactive, that means that I can zoom on it.
Means that usually this is something that has Python to save resource of the system. For example, if you draw a figure there, every time that you move something in your system, window in the system, you overlap the figure or whatever, the system needs to rewrite again all the screen. That's happened in all the operating system, in Mac, in Linux, everywhere. Okay? So, and by default, in all the codes of the program to make plots, like IDL, MATLAB, the interactive is on, always, and you cannot take off. That means that it's taking a lot of resource of the system to redraw the figure every time you move the mouse over the figure. So by default, this is disabled in Python. So you can plot, and the figure is there, and you cannot type anything until you close the figure. This saves a lot of work for the system. But if you want to interact with the figure, let's say, okay, let's see if I can zoom here or whatever, then you have to put interactive on. That means that I'm going to interact with the system. Okay? Sometimes maybe you don't want to interact, just make the figure export and go on. Okay? You don't want to interact because you made the figure before and you know how it is. You want to create again only. Okay? So the first thing is to make interactive. If we are going to work and see and change things, interactive on, on. Okay? For example, think about that you want to create 100 figures, just changing one parameter. You don't need to show the figure because it's going to be the same, just changing one parameter. So you will use E off. So that means that you are not going to see the figure in any place, but the figure is going to be created saved in the hard disk in the format that you want. PDF, PNG, GPJ, whatever. Okay. So this is very interesting. For example, if you want to generate the figure in a different computer, so you connect to that computer, but you don't want to wait that that figure, the window in that came up to your computer. You want to create the figure and you don't want to see because you have created before. Okay. This is also why you can use interactive off. But now, for this example, because we want to play with the figure, we will use interactive on. in a similar way, we will use PL show. That means that the plots will be shown right after plotting. For example, think about that. Okay, I don't want to show the plots until the plot is finished. So you make everything, and you at the end give the command plot show, and the figure will show. This is also to save some resource of the system, or if you want to connect to another computer and you don't want that the figure will be shown. Okay, so PL on and PL show. This is for interactive figure, and this is to show in the exactly in the moment that you to plot anything. Okay. So first, PL on, PL show. And now we plot the data. It's very simple in Python plot things. Just the values of X, the values of Y, and here we are saying that, okay, use dot and color black for the dot. That's it. Remember, this is the values of X that we want to plot time against mass.
No, I don't understand what is point K.
This means
Point?
the point is the symbol,
Okay.
and the K is black.
Ah, okay. K
Black. Okay? So the next day, Mercury, we will show a lot of things about this.
About
About what?
So according to it, I can upload this because there is some.
No, PL show, no, PL plot.
No, but also just if I want to read the data, for example, this one.
No, but, okay?
It's the same.
No, data, how did you call it? Time or to the header? What's the name of the header? Time, so you should put there data time. Data time. There. Can you show me what do you have in type? D types? What is the name? D types. Can you show me? D type. Okay. And now, probably.
No, here.
Yeah. Okay. Now.
Yeah, sorry.
So, do we have the plot?
Questo ti risalvo col formato del link.
Okay, no. Can I click here? Okay. No, that date time. Data mass. Data mass. You missed that. Plot only the given string. So that's perfect. That's perfect. Perfect.
That's perfect.
Okay, you are reading. What about here? Perfect. Perfect. So now with the figure you have in the bottom. Okay, there. No, it's not PL show, it's PL plot.
Oh, that's a good reason.
Perfect. Now, those that are using directly the figure system, you will have some tools below the plot, so you can make zoom, you can pan, you can have a lot of fun.
There is also command to save. Can you save
Save?
find the format that you want?
What you want, you don't.
Can you
it's-
specify it?
No, you don't specify the tail of the file. You say .pdf is PDF, .png is PNG, whatever format you want. How is that? Perfect. So you can play with that.
Yeah, how do I reset the image?
PL CLF. PL dot CLF. A function. There. Okay? Perfect. So you can play with this, making zoom, pan.
Okay, and if I take this one,
Yeah, show you a lot of
means that I need to add all these.
Sorry? No, yeah, you mean to change things?
The line of command.
Yeah, in the line of command you have to specify everything. For example, instead of point, you can use circle, square, hundreds of them. We will see this in 2 days.
Sebastian,
Yeah.
remind me again. How do I go back to the history?
You have to remember log on with the percentage, log on, and you have to say.
No, is there no way I can show the last 20 comments?
With you have to set up the log on at some point.
Okay.
Log on.
Okay. Otherwise,
Yeah, or you can place the first. You know the first letter, just the first letter and.
Okay, so it's
That's right.
Okay,
Yeah.
okay.
Only you starting with P.
Okay?
Good. Great.
And I can
No, non
also,
sposato, però...
I can also make operation within out the column. If I type
Non devi
data
scrivere
time
PM show.
plot multiply data mass is making the multiplication of the column of the two array.
If you want to plot the multiplication, for example, yes, there. You can take this and multiply by 3 here directly.
Directly in the plot.
Directly you want, or create a different array. But you can do directly whatever is going to keep here is going to process. It could be a number, could be a calling to a function, could be a multiplication, whatever. It's going to process, and that is the first x, the independent variable. Okay? So, okay, everybody has the figure. So everybody has the figure, right? Yeah. So let's fit a linear function here.
Why is not the same the number of options that one has in the...
Oh, but that's depending on the system. I mean,
For instance, here's this option that I have.
well, yeah, no, you have here. It's there. Yeah. It's in a different way, but it's there. That's the same.
Please modify the
Yeah.
relation of the plot. No, you can also put the no standard.
Where? Ah, there. Oh, you mean that one?
Not here.
I don't know, probably the version of Matplotlib. Are you using Matplotlib? Yeah. PyLab.
Yeah.
Yeah, it's different. Okay, so with the arrow you can go to different versions of the same. With this arrow you can go back and, okay, go through all the modification that you have performed. Okay, so let's make a fit. This is a very simple package in Numpy, which is called polyfit. It's very simple. You give the independent variable, the dependent variable at the degree of the polynomial you want to fit. In this case, let's fit a straight line using data, our values of x, which is data time, our values of y, the dependent variable, data mass, and the degree. And this will be keep it in this. This is a list on a Numpy array which contains the coefficients in this way. Okay? So the first element of this, the output, is the coefficient of the highest grade of the fit. Okay? So at the end is the 0 point. Okay? Of the fit. So let's fit and see what is PP. Polyfit. Let's use polyfit.
Is there any way to see the coefficient fitted?
Yes, PP enter. That's
Okay.
yeah. The first one is the
At zero,
the slope,
is a 1.
and the second one is the 0 point
Okay.
for a straight line. The first one is always the highest coefficient, the coefficient of the highest degree.
Does it also fix the errors?
Yes, I will show you now. Show the error of the fit and the error of each coefficient.
How can you see the coefficient? PP
PP enter, or print PP or PP enter. Okay. The coefficients are there.
and the first is the slope and the
Yeah.
point.
In a straight line, yes, but we can also fit all the time. So it's very interesting to evaluate. I mean, if we have the coefficient and we want to evaluate our fitting function to another point, we can use polyval. It's very simple. Polyval, we give the output of the fitting and where we want to evaluate. That's so simple. So we can plot directly the fitting by using this. For example, now we have our fit, the slope and the 0 point. And now let's create, because we want to plot there, let's create a linear spacing x value between the minimum and the maximum value that we are having in our data. Our minimum value, remember how to say to know what is the minimum value is the data that we have in the x-axis minimum. This is the maximum, and this is the number of points. So linear space is going to create between the minimum data value that we have, the maximum data value that we have, 100 points. So it's moving, so we can plot our result.
Otherwise, I can also plot the line.
Yeah, but wait, because the line could be no order, right? It's going to, for example, if the line is not increasing with x, for example, if the data is not increasing with 8, and you use that to plot the result, maybe it's going to connect the lines in this way, okay? Because it's not x is not ordered here, should be not ordered. So for that, for a very uniform, you create a very steepy value of x and evaluate the result of your function, your model, in those points with polyval. So polyval, we give the result of our fitting, the coefficients, and where we want to evaluate. This could be 1 point or could be an array of points like in this. And we plot, we say, okay, plot x, the result, the prediction of our model with a line, continuous line in red. Okay? By default, Python overplot on the viewer. Doesn't remove what you have there. You want to be removed, you have to say directly with whole files.
Keeping the same scale as the first one.
No, this adapt to see the full everything. Yeah. But you at the end you can push your limit. When you are finished, you can set up the limits. But yes, it's adapt always to show everything automatically. Okay, let's plot our result of the fit. Perfect. Perfect.
Okay.
Yeah, but you have to say, okay, and now you plot.
Devo chiudere la pagina di...
Yeah, perfect.
Ah no, ecco. Ah sì.
Good?
Anche qui.
All have the fit. Yeah. Okay, perfect.
No, ma what I don't understood is okay. I understood the logic, but once I have the coefficient and the slope, I could. My idea is why I cannot plot the function directly without computing at given value and then connect.
You can plot directly, but you have to create. You have to arrange what's the coefficient multiplied by x, and then add the second coefficient. It's more easy this way. Remember that this is okay. Probably it's not so much effort for a straight line. Or think about a large polynomial of degree fifth degree. You have to type all the multiplication. Okay, let's calculate errors now in the fit. Here we wait how to weight fit and calculate error. Okay? It's very simple also. What we have to say to polyfit is just to give in return the covariance matrix. So let's read a new one. This is very easy. 5 data fit 1 is simple. The first header I think is commented with the usual hashtag, and there is no any other complication there is no mixture of strings and numbers, so we can use directly log txt. And because we are using unpack true, okay, and we know there is 3 columns, directly we can give the output to each variable. The first one will be x, the second one will be y, and the second one is the error. So with unpack true, it's going to take the first column, put here, the second here, and the third here. Okay, let's do it.
Sorry, what is again the difference between unpack true and unpack false?
Instead of read line by line, it rotates the output. So if you directly give this one, what is going to read is instead of row by row, it's going to read column by column. Because when you save with save txt is in the way that is the way you save.
Okay.
So with unpack true, is the usual way to read row by row. Let's read this one. Data fit 1, and let's try to fit a straight line. First, we are going to plot the result with a new command, which is called error bar, to show error bar. So, load txt, name, unpack true, because we have 3 columns, first to x, second to y, and third to error, s. With error bar, we have to say, okay, this is our x value, this is our y values, and these are the error, with the keyword er equal to s. We have the third column is the error. This is the marker that we want to use. This is ms, is a concentration marker size, so you can put marker size or ms. Marker face color, none. Marker edge color r. Line style, none. And color red.
Actually, what is the advantage of reading the column with this command with respect to the other one? Because
if you remove this, it's not reading row by row, column by column. So the first variable is not as you expected.
No, this is different, because before we read the file, right?
No, yeah, because we use gem for txt because there was a mixture of numbers and text. You can use also that here, but you have to define the types. And because all the numbers here is the same, you don't need to define the types directly. The most easy way to read in Numpy, if your file is all numbers, doesn't matter if are a mixture of integer or float, doesn't matter. If in your file there is a mixture of numbers and letters, this is the easier way. Okay. Also, you can skip rows here, right? You can say skip rows, 1, 2, 3, or if the header is commented with hashtag, it's going to jump that row.
But in the previous file, the only difference was that there were the
We have string.
the separator.
No, string.
Ah, the string.
String.
Was data.
This is string. Okay.
What's the meaning of this error bar container?
That's the output of the information.
It's
Not an error.
Okay.
It's
No,
not an
error
error.
bar. Yes.
Okay. So now,
No, okay.
so all have the error bar plotted. Now we make a polyfit. Now we say, because we want to get the error of we want to have the error of the coefficients. We say cov equal true in polyfit. That means it's going to return the covariance matrix, and from there we can take the errors of the fit. So cov equal true, and we want to weight with the error also. It's not. I mean, these two things could be independent. What you can weight with error and don't have the covariance, don't want to have the covariance matrix. But here we want weight with the sigma. This is because we use W equal sigma, which has been written here, is the column sigma, the column third, and we say covariance true. So give me back the covariance matrix and the degree. So because now the output will be two, the polynomial and the covariance matrix. So make the fit and see what is the content of PP and PC.
I can give as an expression. I mean, I can use an expression instead of a column for the weights.
Yeah, you can give.
It's like, I don't know,
I mean,
square root of one of the two columns.
yeah, for sure, yeah. But if you give a single number, it's not going to weight it because all the value has the same weight.
Yeah.
It must be the same to make sense. Must be this column must be the same side of the
Yes.
x and y. But you can give any expression, even a function cal,
Yeah.
whatever. Okay, so what is the output? For PP it should be two number, the slope and the third point.
Yeah.
And for the covariance matrix, a matrix 3 by 3.
Yeah.
Sorry, 2 by 2 because 2 by 2 because the degree is 1. Okay, and we have two coefficients, 2 by 2.
I can erase the
PL, clean, CLF, CLF, function. No, CLF, CLF, function, parentesi. Okay? So the error of the fitting is the square root, the sigma of each element of the fitting is the square root of the diagonal of the covariance matrix. Oh, this is say PS, but should we say PC, right? Sorry. Here is a typo here. This is the covariance matrix, which is PC. PS is not defined. So we have the error of the fitted coefficients.
Okay.
The first one the slope, the second one the 0 point. PSPC is a mistake. There's a typo there it's not PS, it's PC. It's PC, right? There is a mistake.
Okay.
Okay.
Okay, that's there. Perfect. Okay, now the plot. If we want more information to take residual, singular values, or relative condition number of the fit, but not covariance matrix because this is excluded, we should use the keyword full equal true. This gives not us the covariance matrix, but give a different information. Full true, and we will see what is the output. Okay.
If I want to plot in two different plots, I have just
Different
to,
figure.
Yes, I have just to define a new plot variable.
Yes. Okay. Now you want to
plot one.
Yeah.
And work.
You want two figures, separate figures. Just type PL figure, and it will open a new one.
Okay.
PL figure. We will see this in today.
Okay.
In Python, you can open any number of figures that you want. There's no problem with that. Okay. Repeat that, and that's the covariance matrix. No. The output of the covariance matrix is in PEC. Okay, the first output is the fit, and the second is the covariance matrix. The square root of the diagonal of that matrix are the decimal of the fit of each, not the decimal of the fit, the decimal of the elements. The decimal of fit can be calculated with the residuals, right? Okay. Okay, MP, have you imported with MP? No.
I think so.
No, yeah. So match between arrival object. Okay, what's
It's percentage
should
dot.
be? No, it's okay. It should be okay. Format.
Today allora safety thing.
Okay.
Anche lui. We have the same error here.
Because the format. Oh no. Wait. Yeah, PP. Yeah, PP because PP is not a number, right? What is PP? Oh, you have to take the first.
Okay.
Because PP contains now the full matrix.
Tuple.
So now you only want to save the coefficient. So PP is 0, 1, 2, PP 0, for example.
This saves only
No, okay.
the first line.
The first line, so now, because we have put everything in one variable, when we say full equal true, there are a lot of information there. Okay? So are not array, it's a tuple. It's a tuple. See? It's a tuple.
Okay, so now it saves everything here. And it's
Coefficient
format,
1.
but the format is strange.
Yeah.
It's going to first.
Yeah. Coefficient 1.
It's not going under CFF2. It's going.
Oh, yeah, this is.
Is it because of the slash n?
Ah.
Slash d?
Yeah, that's it. N. Yeah. No. Because this is safe text is safe in this way. Okay. So if you want to first go, for example, description is slash n.
Here.
Yeah.
Here.
Yeah. Now,
Right.
coefficient 1, coefficient 2, and then the description. If you want it in row by row,
Yeah.
then it's not the best way to use save txt.
Okay.
Okay?
Okay.
We will see how to do that. This is line by line. Okay?
Ti dà un mismatch.
Sì. E devi fare PP0.
PP0, sì. Because PP contains is a tuple, because we have put everything there in the output of the full.
Prima.
No, PP0 is your.
Sì, dentro
Il
la
save.
dentro il save, non devi dire PP, ma PP0 perché
PP0.
il formato è sbagliato.
The first element of PP. No PP0, sino the first element, the index 0 of PP.
Qui devi chiudere la virgoletta là.
So with
Parentesi.
parentheses.
No, that one. Where? Okay, that one. So if we want, for example, in each column will be this way. For example, we want, let's say that PP is like this, 3.5 minus 0.3, right? We want to say that's PP, and we want to. That's PP, okay? And we want to save in a file. So we say with open my results that as file for P in PP. For first let's write the header. So filer, write the header, right. Let's put this to read the column 1, column 2, okay? And now for each element in PP, we can write the result. Let's say 5.34. We can do it this way, which is going one by one, or we can write all the line at the same time. We don't put here, because there are only two elements, we don't put a escape, return of in each line, in each element, like this, and P, okay? Oh, we have to give some space here. So we repeat that. Some space here. Okay? See. This is the header, so we write it. And now for each coefficient in PP, we'll write the coefficients in the same line because there is not return here, right? So it's going to write every coefficient, each coefficient in each column with this formula. Okay. An exercise here. Let's try to work with data feed or data feed 2 or data feed 3, read the data, plot with error, fit a polynomial of the degree that you think will be, plot the result and save the results. You can use, to save the result, you can use this thing. Right. So try to fit a polynomial with I think there's 3 columns. So try to weight with errors and get the uncertainties of the fit of each coefficient.
Come dici? Data pick 2, sì. So the third column in the polyfit, when you estimate the covariance of the matrix, these are weights.
Yes, yes. W mean
W
the third column. No,
yes.
no. The third column could be anything. The keyword W equal to whatever is the weight. This could be placed in anything. But here, in this example, is the third. But what is placed is
anyways,
always
what it needs is the weight. It doesn't,
the weight.
It doesn't have the sigma, the RMS.
No, no.
Just
If you want to weight with the sigma, that is the weight. So it's going to divide by that thing, the value.
Okay.
So the weights, if your weight is the sigma, that is what you have to put.
Which usually is the inverse square.
Yeah, no, I use that. So the weight, if the weight is the sigma, so it takes the inverse of that. You can say, okay, I can show you.
Okay, so it uses the weight. The
You
quantity
don't have
give
to
is
divide.
the weight.
You don't have to invert that thing.
Which means that if you have a sigma in your table, then instead you need to invert it.
No, you don't need. So here.
Okay.
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 Okay. For Gaussian uncertainty, you should use this one, not this square. Okay. So, way to apply the e-coordinates of the sample point. For Gaussian uncertainties, you use this one, not this the.
Anyways, I need to first invert the quantity.
If it's not inverted in the array, that's right. But in this array is already
It's already
inverted. So
inverted. Okay. Thanks.
that's just an example. You can use it. Okay, so the first one is a polynomial of second degree with these values. These are the values, and
Using command line, how do I save figure?
uh,
Save figure, right?
yes, PL, not Numpy.
Oh yeah.
PL.
So,
Say fig, the name of the fig, and the which include the tail is the format, PDF, PNG.
come figura.
Okay.
No, io sono molto indietro.
Ok, poi come puoi utilizzare lo residuo?
Residual is you can complete by yourself, or you can put full equal true and give you the residual. If not, if you want to compute the residual by yourself, yes. Use in the polyval, give the x that you have used the data of the data, and subtract
Okay.
the output of polyval of the values of y, and that's the residual.
If I want to know how much good is the fit, there is something that...
Yes, there's CP has more data. You can directly calculate if you divide the variance of your data respect the variance of the result of the residual, this give you directly the value. Or you can apply Pearson. You can calculate the Pearson coefficients, chi-square. But I think CP has a more function for that. We will see. Numpy, I don't know if it has a Pearson. Let me check. No. Full. So the full. Yeah, it's doesn't give so many options here. Oh, return residuals, yeah. return residuals with full residual, rank, singular values, and recount. So this will show you some information about the goodness of the fits. But for example, SciPy has more tools to calculate directly the Pearson chi-square and so on.
But this is
Pearson
for,
goodness of the fits.
this is for polyfit, no?
Yes, polyfit.
Ah,
Polyfit, when you set up full equal a true, give you this information. Okay, Lina, ¿cuál es this one? This square.
How do I save it like a JPEG?
With the GPAG.
Yeah, I mean, I understand it, but then should I give it something like that?
No. Remove that. Just with this page.
You already recognized by itself that this is a JPEG. What about if I want the INAF? Yes.
Yeah, sure. PDF works.
Okay.
All this stuff works.
Okay.
E tra parentesi grafici prima del file confermato. Dai, è stato più regolare. Ora meglio di tutto.
Yeah, so residuals, return residual, rank of matrix A, singular values. Okay. What about the second one? For example, let's say we have, let's plot the other one, 53. Okay, let's plot first. With this compare, close all the figures that you have open. Okay, this is one. Oops. Okay, so this is the data feed 3. And the fit. So the coefficients. Okay. So with save fig, we can save the figure, for example, in a format that we want, PDF, PNG, JPG, whatever you want, okay? Bitmap. Any question? Okay, so now we have to deal with Numpy. Make some fits and plot the basic plot. Next day we will see more sophisticated plots that will be only focused on make figures. Okay?
And so next class will be on mercoledì alle 9. 9:30, giusto?
9:30 o 9?
9:30.
9:30.
Scritto bene.
Perfetto.
Va bene.